Dear friends, this is Indra V. Chapter here in the episode of Mathematics and Statistics Learning. In the previous 9th and 10th episodes, I considered pie chart and bar graphs for displaying statistical data. Today in this 15th episode, I would like to discuss graphical display in algebraic context. That is, the visual display of the given algebraic function using graphs to illustrate the behavior and pattern of algebraic functions. A graphical display refers to the presentation of information or data in a visual format, utilizing images, charts, graphs, or other visual elements to convey complex information in an easily understandable manner. Visualization in mathematics is the art of representing mathematical concepts and structures using visual elements such as shapes, colors, patterns, and animations. It can help us understand complex and abstract ideas, explore new connections, and communicate math to a wider audience. Through the graphical display of algebraic functions, one can gain intuitive insights into mathematical relationships and properties. Graphs provide a powerful tool for solving problems, perform analysis, and communicate mathematical ideas, especially for gaining insights into real-world scenarios. Nowadays, graphical displays are widely used across various fields and become an integral part of our day-to-day activities due to their effectiveness in communication and information processing. Graphical displays are preferred because it is easier to understand a picture more quickly than a block of text or collection of numbers. That is, visuals are more effective than text in human understanding. Information can be presented in an attractive way and in an appealing form. Visual displays are considered one of the most important learning strategies. It facilitates and improves learning. It eliminates language and literacy barriers. Information in visuals is concise, consistent, and compact. It saves time in daily life. Graphs help make an analysis to make quicker decisions. Visual provides clarity of communication and more focused on the specific areas that needs attention. Unfortunately, visual display is not possible for dimensions higher than 3. Here in this discussion, we shall consider graphs of one-dimensional, two-dimensional, and three-dimensional. I have listed below the link that will lead you to the site that explains the procedures in detail. The one-dimensional plot is to represent real numbers. Each point on the number line corresponds to a unique real number with a single coordinate on the real line. For a visual example, browse this web page of mine. On the Graphical tab, click Graphical one-dimensional app on the right of Graphical app. You will reach to this page. Click this button. Here we can see one unknown equation and its point solution. This point solution is displayed here in one-dimensional graph, a real line. You can have the actual experience of a one-dimensional plot, the movement of this red dot by clicking this button. On the click, equation changes and also the solution, which makes this red dot to move. The two-dimensional plot, commonly known as the plot in the Cartesian plane, is a powerful visual representation in algebra that extends the one-dimensional plotting into two-dimensional. That introduces axes, the x-axis and the y-axis, perpendicular to each other, intersecting at a point called origin. Points on this plane are represented as ordered pair x, y, where x denotes the horizontal position along the x-axis and y denotes the vertical position along the y-axis. The Cartesian plane has become a cornerstone in algebraic studies, offering a dynamic and intuitive means of exploring mathematical concepts. For a visual example, browse this web page of mine. On the Graphical tab, click Graphical two-dimensional app on the Graphical app. You will reach to this page. Click this button. This opens a data table and the corresponding scatter plot. In the scatter plot, you can see the axis, this horizontal line x-axis, and this vertical line y-axis. They intersect at this point 0, 0, called the origin, also the reference point. X values measures positive on the right of this point and negative on the left of this point. Similarly, y values measures positive above the x-axis and negative below the x-axis. Each point is leveled with corresponding coordinates, the pairs x, y. The first x value measured along the horizontal axis and the second y value measured along the vertical axis with appropriate sign. Keep clicking the next plot button to have the changed values of the data table and the corresponding change on the scatter plot. I will show you here the beauty of this plot, the great surprise. Most of you might not have seen this before. Grab your mouse and click somewhere inside the plot. Look at below the plot what is printed. The coordinate of the clicked point. Keep on changing the click location and see the corresponding change on the print. Isn't that it cool? The three-dimensional plot is the extension of one more dimension of the two dimensions, the last possibility, beyond which only the theoretical formula exists, not the visual display. Practically, in a real-life situation, we can assume that three-dimensional plane is the room where we are sitting right now. The floor is a two-dimensional plane. The addition of one dimension, the height, makes it three-dimensional. Any point with the coordinates x, y, z is on the space hanging inside the room. For visual example, browse this web page of mine. On the Graphical tab, click Graphical three-dimensional app on the right of Graphical app. You will reach this page. You see here the data table of the values x, y, and z below here and the corresponding three-dimensional plot above the table. Compare this plot with the room that we are sitting in right now. We could imagine that the coordinates, the point x, y, z of each point looks like a hanging point on the space. In reality, this is a three-dimensional drawing in two-dimensional plane. That is, we are pretending two-dimensional plane as a three-dimensional. Keep clicking the next plot button to have the change data table and the corresponding change in the plot. The interesting thing here, if we click inside the plot, we see below the print coordinate of the selected point, but we didn't see that Z value, which is blank here, because the mouse always clicks on two-dimensional plane, not on the three. Is not it the paradoxical curiosity of the reality?